Senior Vice President Sales, Business Development, Marketing, and Legal at ASP Group. Microphones, please. Microphones.
יש להם על הכיסא.
You have? Oh, okay. Great. So, I should use this one, or do you have another one for me? Okay. Good evening, everyone. Let's warm up one question to all of you. One of the most challenging issues is to try to project the future. But what do you think will be the three most important technologies that will impact the semiconductor industry in the next few years? You want to start with that?
Happy to. I'm being paid to predict the future.
Okay.
So, I'm going to start with the obvious. I'm sorry, but artificial intelligence is probably one of the leading trends. It's been a leading trend for a while. So you want to say something?
Wow, surprised.
No, but artificial intelligence. Most people look at AI as something that something that forced the semiconductor industry to incorporate or develop AI-ready hardware. But semiconductors companies are also integrating AI into their manufacturing workflows to improve product quality, to optimize operations. We're seeing semiconductors companies using AI to identify design limitations, to do root cause analysis of failures. So it's not only the obvious thought about AI as accelerating or increasing the need for advanced processing. So AI is starting. And I'm not going to talk about structure because I'm sure people are going to talk about structure. It's the thing, architectures and materials, advanced materials. And it's not only looking for reduced structure size. It's also leveraging in novel materials that allow for anything from a higher voltage resistance, higher operating temperatures, faster switching, reduced form factor. But my favorite is advanced packaging, where manufacturers can now package or merge various components on a single electronic device, which of course improves performance, cost, price. And those are my favorite. Those are areas that we're looking at a lot in the last couple of years, but I'm sure there are many more.
Sure. So let's leave more to others. Who wants to go next? Christy.
Sure. So I would say that probably one of the bigger trends that are going to happen is the redrawing of supply chains globally, right? We're seeing, obviously, we talked a little bit about it this evening, geopolitical challenges in our world, and as we think about the different countries and their competitive advantages, whether that's manufacturing, whether that's talent, whether that's design, but seeing countries really think about how do they want to participate in the semiconductor ecosystem because it is becoming so pronounced. Everybody now knows what semiconductor is, right? I've been in the industry for about 30 years with Deloitte, and interestingly enough, 30 years ago, you had to explain what it was. I had to explain it to my brothers and my mother and parents, and today they all know what it is. And so I do think that semiconductor industry is going to be very important for the economics of many countries. And as we think about the geopolitical challenges in Asia, the US, and whatnot, I think that's part of the reason why we have the government funding in the US as well as Europe. And so when we look at what back end, manufacturing, design, and what those resources are in various countries, I think that we'll see some of the migration of resources globally in various parts of the world.
Thanks, Christy. Ori?
So we certainly see the semiconductor world as vibrant as ever before, right? There's been geopolitical movements, developments. There is discussion in the government levels. We've seen Biden holding a wafer and saying it's a critical resource as water and energy. So it's as more vibrant than we've ever seen it before. And I think in terms of technology, you see in every aspect of technology, there are a lot of progress being made from material perspective, geometries, EUV development, and we've heard from the TSMC presentation, we are talking now freely about 200-meter devices, where we thought at some point that maybe it's hard to get. So I think all these segments are operating in parallel, and on top of that, we've seen a lot of end-user demand that's very aggressive too, right? In the past, there used to be, in the last 20, 30 years, there used to be like one leading factor and everything followed it. Now we see multiple factors and they're all pushing. AI is one of them, but there are many communication, 5G, fibers, and so on. So
Yeah,
a lot of
you know, my question was to try and point out three major technologies, and I feel that we start talking about everything that is moving around. You know, try to, if I'm an investor, try to help me put my money on the right technology. What should I look at? What will be the major technology space that will impact our industry? Can you elaborate on this, or maybe we'll let Ian talk about it?
Well, I think, I echo some of the earlier speakers. I think, me being from the AC group, we're leader in packaging, and it's so refreshing to hear packaging now as part of consideration of silicon design from the onset, from the architect standpoint of view. And so with advanced packaging, it's one of the key pillar and key mover or more than more ball. So I think we're very excited about that. But one specific things that we also are very interested is this integration between photon and electrons. We're now integrating not only on the silicon level, but now we're putting silicon photonics into the package. So this integration of photon and electrons, I think, could be the next advanced packaging innovations from our standpoint.
I see.
You have two out of the four saying advanced packaging. I guess that's a thing.
Yes, absolutely. If we have investors here, they should put their money on advanced packaging. But let's go to another thing that you mentioned, Renana, and this is AI. And we're talking about AI in many ways, but the question is, how do you see AI affecting your life? How do you see it in the day-to-day? Do you feel it? Do you use it? Do you feel that it changes your life?
So I read recently that the NVIDIA CEO said that we're living through the iPhone moment of AI. And because large language models combined with very, very simple UI are all of a sudden accessible to anyone who wants to play with it. And just like the iPhone put in the hands of billions of people the power of semiconductors and advanced processors, all of a sudden those billions of people have the power of AI in the palms of their hands. And we're seeing what happens as a result of that. We're seeing a ton of innovation that touches everything from how we write essays, right? How we generate reports, how we create materials for marketing and sales, HR. And the potential is really incredible. So on one hand, the generative AI and the fact that Microsoft is now pushing AI into all of its products, this takes away a lot of the moats that startups used to have. Me, from my narrow perspective as an investor, all of a sudden the way we look at startups and their differentiator is very different because things are easier to do now. But on the other hand, all those tools that are being created around us are allowing people to do much more with much less. So assuming you can create some sort of moat, and assuming you can leverage unique or proprietary data sets or deep vertical expertise, then again, we're seeing incredible companies that are being built.
Bigger challenges with bigger tools. Christy,
Yes.
what can you tell us about AI in your life?
Well, I think when we think about AI, right, especially AI in semiconductor and primarily design and design engineers.
The question is not necessarily about semiconductor, but how how do you feel the
In my
AI impact you?
in my life. Well, learning about it, for one, obviously, but I tend to agree with you as well that it will create a lot of efficiencies in the talent models for people, like teams, people that we work with. We've incorporated it into our businesses at Deloitte, in our audits, and the technologies that we use. And so, in my work life, I think from an AI perspective, there's been an impact. But then in my daily life, right, ChatGPT, I mean, we ask questions, and it's so interesting to see about that. But I also think about it from just where we're going in the industry as well, right? And you think about the talent equation, talk about the cost of talent, and how do you, the talent demand that there's going to be in an industry, and so how do you help educate people to use AI? What's it going to look like? What are the operating models? So I think about that as well. We talk to our clients around strategy. What is that going to look like? It's an AI revolution, we have the computer revolution, we have the internet revolution, the cloud revolution, we have the AI revolution. All of that changed the operating models of the companies and our clients, and that's something that we think about on a daily basis.
Okay, thanks. All right.
So we actually see it in three places. First, it's the end user demand, right? We see a lot of demand for our products because of that. But we also see it in our algorithm. We've been working on AI for years now, and we've implemented our own Kelly proprietary algorithm, and they are actually helping us make our system more robust. And we see huge process variation with the new technology nodes coming in place. We need to address that. We see geometries that are complex, aspect ratio, different thicknesses, and so on. So this algorithm actually are changing the way that our machines are working and helping yield products. And so that's the second in our tools. And the third is actually in our business environment. We get a lot of data from around the world for our suppliers. We get a lot of data as we manufacture these machines. All this data is actually very useful, and this algorithm helps us break through and understand how to act based on what we get from this. So a lot of impact every day.
Thank you. Yin, you are a Senior Vice President of Sales, Business Development, Marketing, and Legal. What impacts you the most using AI?
I think we think about it in the most practical sense. So AEC has been working on lights out factories for past 5 to 6 years, and AI has been instrumental in doing that. During the year 2020 to 2022, the semiconductor industry experienced extraordinary growth, and AI helped us manage our costs by allowing us not to increase so much human resources as demand requires. So AI helps us in terms of doing the predictive manufacturing that everybody's fighting for. So that's very practical benefit to us. Second is, as other speakers mentioned, we are now using it in simulation and engineering efforts. AI help us in simplify some of the, I would say, daily tasks dealing with customers, doing simulation, doing variant analysis. So those are very practical benefits of how a manufacturer such as AEC Group can use AI to everybody's benefits.
Great. Before we go to more personal questions, I want to address you, audience. First of all, I apologize for the fact that Ronnie Friedman, General Manager of Apple, was supposed to be here, and unfortunately he said he cannot be here, and he even found a replacement, Mr. Talim Bar, that had an emergency with his daughter, so unfortunately we don't have the Apple representative here. The other thing I wanted to tell you is that I'm here as your representative. I'm trying to ask the audience, the panel questions that represent your interests, your ideas, but maybe you have some specific questions. So I'll leave some time at the end to allow you to ask the people here some questions. So if you have something or if you want to think about the question, please do. I'll allow you to do it later. Now, let's go to more personal questions, and the first one is to you, Renana. I know Grove very well. I know Don Moran, who founded Grove, and I know that when you started the Grove Ventures, you had kind of a declaration saying we're going to invest in semiconductor. And after a while, you change it to we're going to invest in deep tech. And now you're saying you're going to invest in future tech. So what happened to the semiconductor companies? Are they gone or what?
You see, you call it a shift, I call it an expansion.
You're very good in marketing.
ChatGPT helped us with making our messaging very concise. I'm joking. When we started the fund in 2017, and like you mentioned, we're 4 partners today, and out of the 4 partners, we're 3 with significant experience in the semiconductor industry. So I've spent most of my career in applied materials, so obviously has some connection to semi. Leo Hennis, one of our partners, is one of the founders of SolarEdge. And when we started the fund, we said we're going to be the first fund in this realm to focus on, we called it in the first day, we're going to focus on deep technologies. Because we looked left and right and we saw that most investors wouldn't get into startups at the time of day, right? It was scary. And we called it, we said we're looking at hard tech. And we called it hard tech because we said the startups that we're looking for typically contain hardcore science or engineering component. They'll typically include hardware as well as software. They're hard to do. The good ones are hard to copy. And the venturable ones, the ones that are appropriate for venture funding, are hard to find. And semiconductors definitely falls under, or definitely checks all those marks, right? And so from the very first day and to the day, every year consistently, we've invested in at least 1 or 2 semi companies. But semiconductors is not the only thing that falls under those categories. So true, we're investing in other technologies as well, but 90% of the companies that we invest in have a core, their core is the technology. The differentiator, their make or break is going to be technology. Many of them include hardware. We've never had a portfolio that's solely concentrated on semi, but it was always something that was in the core of our investment focus, and it still is.
It's a good way to put it, but allow me to say that there are not enough semiconductor companies.
100%.
So
100%.
there is a problem not on your side, on the other side, and we should address this issue. Why there are not enough new startups in semiconductor?
You're 100% correct. And by the way, that's one of the reasons why we've never said we're going to be a semi-venture fund. Because, if you think about the model of a venture firm, we took $200 million today, already $500 million from investors, and we need to return that money. And it's very difficult to return that if you only invest in semi, because there aren't enough companies. And there are various reasons. One, a lot of them are very, very capital intensive. 2, it takes a very long time to reach commercial stages. 3, it's very hard to fund. It's very hard to raise money. So we'll invest, but how many other funds are going to? It requires very, very specific talent. And so and of course, you're fighting the incumbents that have a lot of money. And so I agree, there isn't enough innovation, but there still is quite a bit.
Yeah, 3 in 2020 and 4 in 2021 in Israel. Only, but never mind. Christy, we started to talk about AI, but I think one of the most interesting part of AI is to have tools, semiconductor development tools, EDA tools that are based on AI, and David just touched this issue a bit. But you, I know that in a previous interview that we did towards ChipEx, you said that you see investment of about $500 million in EDA tools based on AI in the next few years. Can you elaborate a bit on this issue?
Sure, and I think you're referring to our TMT predictions on AI and EDA. I think what we're predicting is that there will be growth in AI from the EDA tools, but I also think there's some challenges. So we talked a lot tonight about EDA and AI, but it solved the design trifecta, so to speak, which is optimizing the PPA, optimizing time to market, and optimizing the cost. So those are three areas that AI could actually be helpful, and time to market is what we've been talking about a lot. But that will probably grow faster, the AI component, than just regular EDA tools. And Synopsys is here this evening and talked a little bit about that, and also moving EDA to the cloud as helping the time to market. But the cost for that is going to be an ROI, because you will be able to use your talent. Now, we're estimating that there's going to be 50,000, a need for 50,000 engineers in the U.S. over the course of the next 3 to 5 years. That's just the U.S. You're seeing this growth and explosion in the semiconductor industry. Talent is a key component of that. So how do you maximize talent? And I think AI, we've talked about that, right? Where you're going to be able to utilize the talent more effectively. You can use AI in order to do the minimal tasks while your engineers are doing more creative aspects for design of chips. It will also, I believe, create new business models for some of the larger companies, right? You can have non-recurring engineering as you think about the generative AI. So your foundries, your fabs can be doing some of those designs for fabless companies where you actually want to be a second source or a third source for manufacturing. We talked to a startup today thinking about, okay, once their product explodes or it gets a higher demand, will their foundry that they're currently using be able to supply that demand? Will they need to have another foundry? You can't just port designs from one foundry to another very easily. So it would be a competitive advantage for some of these other foundries to actually adopt AI. They'd have the designs in order to create the generative AI that's going to be needed in order to help those companies. So I think that will be a new business model that we could see arising from AI.
Thanks. Everyone that is in the semiconductor industry probably knows these three words: smaller, faster, more energy efficient. Ori, what can you tell us will be the key process technologies that will help us make the next generation of chips smaller, faster, and more energy efficient?
I come from KLA, it's only yield, metrology and inspection, there is nothing else. But seriously, we see a lot of designs, and we are always amazed by the complexity of new features. We see EUV coming into play more and more, so photolithography has always been a very important aspect of what's happening in the fabs, and it's just becoming harder and harder to do the advanced processes. But there are other things that are happening in terms of new materials that are being used, that are complex, thicknesses that are much more than we ever seen before, aspect ratio that we never imagined that are possible. For all of that, what we see as an enabler is the control of the fabs. We see yields are becoming very complex to achieve high yields that are economical, and therefore what we invest from our side is defectivity, trying to reduce defectivity, and metrology. Metrology has, in the last 20 years, moved from SPC control all the way to inline, feeding back information into the fab to keep the fab in control. And that's becoming harder and harder to do. We actually have a lot of effort to do in terms of predicting what is the next generation going to be like, so we can prepare the tools for that to be on time. Because without these tools, you actually cannot enable high yields. So we are actually predicting with our customers what is going to be the next step, and we are trying to fit our tools into that. And we do that in defect detection, we do that in metrology.
Thank you. I'm sure you know all that we just celebrated 50 years to Gordon Moore's law, which we know as the Moore's law. And to celebrate this occasion, we decided to award Gordon with the Global Leader Award. And and to make the exception that he will not need to come to Israel because he was 94 years old. Unfortunately, he passed away several months ago, but still I think his legend will keep going for many years. On the other hand, we're getting to kind of the edge of Moore's Law. Just to share with you, the fact that it just kept going for 50 years is amazing. 5 nanometers chip today has 12 billion transistors. But it looks like we're getting to the end of this ongoing process. And right now we have with us Yin, and I would like to ask you, as the industry approaches physical limits, miniaturization, what is the role of ChipEx resolving this challenge?
Well, I think chiplets started out by solving some of the manufacturing challenges of very large monolithic SoC. By splitting it up into a smaller silicon, you improve the overall yield by reducing the defect density. But now with advanced packaging, as we kind of mentioned before, now the architect has tremendous freedom to innovate. Now we're able to take out various IP blocks, whether it's GPUs, CPUs, analog, or I/O input controllers into different silicon nodes. Maybe the GPU will use the latest silicon node, like 3 nanometers, and SRAM and I/O input can use 7 nanometer or even greater. You're able to have a lot more flexibility of integrating various IP blocks, but more importantly, you move into an era where IP block can be easily adapted. So in the future, you no longer have to integrate it. Maybe you can buy an IP block from an IP provider as a chiplet to be integrated into your overall solution on the package. So those are the innovation and creativity I believe chiplet has brought into the industry today that creates new innovative for semiconductors, maybe supporting the new AI that everybody is looking to improve our life with. And for us, AEC, with the advanced packaging offerings such as our DI pack, we're hoping to offer not only the various ways to stack a 2.5D or 3D package system, but also to integrate, as I mentioned before, photonic into the package or co-package optics to improve the overall bandwidth and efficiency of the silicon system on the package itself.
Thanks. Questions from the audience? Any questions in this point? Because I have many questions here, right? So if you don't have, I will continue. And Ian, maybe we start with you this time. Sure. One of the biggest challenges of our industry today is supply chain. And I'd like to hear your opinion about how do you think this could be resolved in the next few years?
I think that's a difficult question. I think it is very refreshing to see global government view semiconductor as a key component of that industry's, or that country's key technologies. It's important as energy or food. But for us, AEC, we continue to look at how do we balance that economic of scales that is tremendously available in Asia with other regions where costs may be a little more expensive. So this balancing act is what we're trying to figure out. We have quite a number of factories in Asia. We have factories in Japan, factories in Korea, factories in Malaysia outside the Greater China region. And then we're now looking at North America and possibly in Europe. So, but it is that balancing act that we're trying to understand what is the best way to support our customer at the most cost-efficient way that fulfill their localized needs, but also offering the cost they're used to, that they're getting product from Asia.
Interesting. All right, supply chain.
So supply chain in the last 2.5 years has been a tremendous issue, right? We've seen many gaps in deliveries. I think right now we are seeing a little bit of relaxation in that. Freight around the world is a little bit back into control. The prices are lower, not completely to pre-COVID numbers, but they are better. And at the same time, we see that our the investment that we've done with our suppliers, that our suppliers did, for us, is coming online. So we see some relaxation. It's not in all areas, but globally it feels like it's a little bit more under control now. So that's on one aspect. On the other aspect, what these 2.5 years taught us is that we need a lot of collaboration. We do that with our customers, so we will understand what they need and we can not spend time going around and guessing. And we do it with our suppliers and their suppliers and their suppliers. We go down the chain as much as needed to actually streamline what we're doing, because this last 2.5 years proved to us that we don't have any slacks, right? We need to be very accurate.
Ladies, can I ask you another question, or you have something very important to say about supply chain?
I would just agree that collaboration is going to be very important. I think countries around the world are really trying to figure out how do they play in this ecosystem, and so I think it's going to ever evolve. And I think I would say the footprint of the supply chain today is going to look very, very different 5, 10, 15 years from now.
And I just want to say that, and I can talk about supply chain forever because you don't know this, but my twin sister is actually head of supply chain optimization at a very large corporate, so we talk about supply chain a lot. And I just want to say that the semiconductors industry is, like we all know, a highly specialized global supply chain industry. And the fact that 80% of the supply chain was concentrated in specific regions shouldn't have made sense in the first place. It made a lot of sense in terms of cost. It made a lot of sense in terms of the fact that each region could leverage its competitive advantage, right? The West with engineering talent, China with assembly packaging, Taiwan with, or Asia with a lot of government incentives for fabrication. But it shouldn't have made sense, especially with Biden holding a wafer and saying that semiconductors is such a critical resource. And so geographical diversification is probably, the only logical solution, longer term and shorter term, all the strategies that Oleg was talking about and so on. But supply chain is definitely a massive focus of the last 2.5 years, and we are seeing improvement.
Yeah, improvement for sure, but I think we see also something else. A few years back, Tom Friedman, the American journalist, wrote a book, The World is Flat. And he said that, right now you can get everything from everywhere and everything is moving fast from one side to another, from one continent to another. But these days we see the different direction, the opposite direction, the West and the East. The West doesn't like the fact that most of the production are done in the East and trying to move it back to the West. And on the other hand, like China, for example, they're trying to build their own fabs, their own design centers, their own tools. They do everything, kind of twice. So we don't see a very good way of working with, supply chain. So what do you think about this opposite direction?
Localization trend, but that's exactly what I was talking about a second ago. That this industry has more than 50 points across the supply chain, where over 60%, 65% of the market share is concentrated in a specific region. The U.S. has those top-tier universities, this ubiquitous engineering talent, so it took the lead in core IP and chip design. And then Asia, with its massive governmental incentives, took the lead when it came to fabrication, right? In 2021, 100% of advanced chip manufacturing below 10 nanometers was concentrated in Korea and Taiwan, 100%. And then China with assembly and packaging. And so it made sense because, like I said, it saved a lot of money. But it's also very prone to vulnerabilities because it's highly reliant on free trade. And free trade relies on the fact that you aren't susceptible to pandemics, to Mother Nature, to geopolitical tension. And that's why we're seeing more and more localization, which on one hand will 100% have an impact on cost, but also create a lot of opportunities. And like I said, it's probably the only logical solution, considering the criticality that semiconductors are now are.
Yes, true. Christy.
Yeah, I would actually say that there's not really localization. There's no country that's going to be be self-sufficient. I think, no country is actually trying to be, maybe China, but I think they have probably a long way to go. China can still play in the ecosystem. What's happening, in my opinion, is export controls and the power, the balancing act of power. The U.S. doesn't want to be the only have China be the only source of chips, right? But China also, their largest import are chips because they assemble electronics. Doesn't mean that they're not going, and we're not going to buy any chips from China. It just means that it might be the lower technology, right? The advanced technology, we want to own that. We want to make sure that we're secure. I think Europe, there's this distrust within the global ecosystem around security, right, and geopoliticals. And so I think, countries are still going to have to evolve. We're still going to be working with China. We're still going to, we're just going to make it harder for China to develop advanced chips. And we want to have our own source for that. Europe wants to have their own source. And then how do you kind of be friends? What are the alliances that you're going to have globally? And so I think you're still going to have globalization. It's just that footprint is going to look very, very different than it has before, and the competitive advantages are going to be very, very different as well, as every country wants to play in the ecosystem.
Yeah. Okay, our time is running out, so I want to ask you one more question. And as you may recall, I started this evening being very positive about the semiconductor industry, so I also want to end it, at least from my point of view, with something optimistic. So I would like to ask you all, are you optimistic about the semiconductor industry?
You have to say yes.
You can answer one by one.
Yes, absolutely.
Yes.
No,
You
it's
can elaborate.
Considering the number of digital devices surrounding us, there's absolutely zero reason to believe that the demand for advanced semiconductors is going to slow down. There are technologies like 5G and crypto mining and big data and AI and automotive, all of those that require increased processing power. There is absolutely, that's why, by the way, the forecast, long-term forecast of the industry is still very, very strong.
Right.
Completely agree. I think, chips are going to be critical, right? And the fact that, you sometimes read in the press that, oh, wow, they built all this capacity and now all of a sudden there's a glut. That's not necessarily the case, right? The demand is going to continue to be there. Chips are everything. AI, just take generative AI, the amount of data that is required for generative AI and the data centers that are going to be needed. I mean, you just think that it's just going to be exponential, the demand for chips in our lifetime.
Yeah, so I agree with what was said here, but we also look at the end user demand, and you see all the segments are on remote everything, right? Remote healthcare, remote schooling, and we spoke about AI, but there are so many applications that are driving high-end demand. That doesn't stop. You cannot get a new car without all the features, and they're all being differentiated by electronics on the engine side, right? So this is driving a lot, and we also see so much money pouring in. We see greenfield fabs. We haven't seen that for some time now. And there is a lot of new fabs. There is a lot of activity going on, and as was mentioned earlier, a lot of money that's bringing into the industry. So I'm very optimistic.
Yeah.
I'm also very excited and optimistic. Obviously we think the demand will continue to grow after the current downturn. But more importantly, I think as an engineer, I'm more excited about all the innovation that's coming out of semiconductor these days. All the photon integration, advanced packaging, going down 2 nanometers, possibly going down to 1 nanometers. It's those innovations that make us excited going to work every single day.
Wow, that's 404. Everyone is optimistic here. Great. So I think all of you and all of us can say we're proud to be part of the semiconductor industry these days, right?
Yes, yes.
So this is a good time to end this panel, and I really want to thank King Cheng, Oriented Moore, Christy Simmons, Renan Ashkenazi for being here with us tonight, and thank you all for being with us at this ChipEx Executive Summit. We're just starting the event tonight. As you know, tomorrow we're going to have a full day of technical lectures and exhibitions, so you're all invited to join us in the Expo Tel Aviv Center. But now, to make this evening even sweeter for you, we have some sweets and coffee and hot drinks for you, so you're all invited to end it with some